So guys, what were we doing last time? I think we were equilibrium कर रहे थे ना, rotational equilibrium. The torque was 0. Yes, no. Okay. So now that you know how to find torque on a given system, we want to take this one step further now. So we want to talk about Newton's second law for rotation. So Newton's second law equal to अभी सही आ रही है आवाज? Is it better now? If my voice is cracking or something like that for you, just log out and log in again. Okay, मैंने waiting room हटा दिया है तो you'll immediately come back. So we know that the second law, we talk about translation. मैंने क्वेश्चन दिया था कोई? क्वेश्चन था क्या क्वेश्चन था? याद है क्या क्वेश्चन था? हाँ 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 You want the final answer or क्या चाहिए? फाइनल आंसर बताओ. आंसर है को निकालना था मेरे ख्याल से. We have to find the normal reaction at a distance which is very large to the right. So the answer is lambda rg cosine q theta by 2 divided by sine theta by 2. आया? Chalo, I'll try to solve. So we have a circle. Draw. And we have a stick. So that this is the ground. Then we have another stick. दूसरा सर्कल होएगा tangential. So दूसरा circle होएगा. Okay, now let's consider this way. इसका हमने यहाँ पे FBD बनाना है. तो इसके ऊपर क्या क्या फोर्सेस लग रही होंगी और हमको क्या वर्कआउट करना है. So we have to work out the normal reaction. No, we have to work out क्या करना था ये मुझे याद नहीं है. We have to work out the limit of very large number of sticks and circles. What is the normal force between a stick and a circle it rests on? Very far to the right. So let the normal reaction on the stick. Let the normal reaction on this stick be Ni here, and let it be Ni plus 1 here. इसके अलावा एक mg फोर्स लग रहा है यहाँ पे, और यहाँ पे एक नॉर्मल रिएक्शन इसी डायरेक्शन में लग रहा है, which I cannot be I don't think I can be sure of the normal reaction. In fact, इसी पॉइंट के अबाउट मैं टॉर्क लेने जा रहा हूँ, so that the normal reaction due to the ground becomes irrelevant. So if I take the torque about this point, right? If I take the torque about this point, this green dot on the stick, right, then I should get torque due to Ni plus torque due to Mg should be equal to the torque due to Ni plus 1. Right? This is okay. Okay. Now let's calculate the torque due to this Ni. What will be the torque due to Ni and what will be torque due to this बाकी जो है forces लगे हुए. So if I remember correctly, this was given as R, okay? And you told me that this angle would be theta by 2, Therefore, this angle would be theta by 2, right? And if I were to draw a vertical line here, and if I were to draw a line to this point of contact, and if I were to draw a line here, then what would this angle? The angle become? What will this angle? This angle. Remember that this is 90 degrees, this is 90 degrees.
Theta by 2.
This is 90 degrees, exactly. Right. So this will be theta by 2, this will be theta by 2. Right. Now we are interested in finding this distance. And we are interested in finding this distance. This distance we already know. Right? Also, remember that my diagram is slightly wrong because ये जो sticks है, उनका जो upper part है वो यहाँ पे खत्म हो जाता है. मैंने ये part जो है extra बनाया. So the sticks they exist only up till this point. So we know then the length of the stick, right? We worked this out in the last class as well. क्या था length of the stick? Length of the stick in terms of R. In terms of R, what was the length of the stick? So right angle triangle का hypotenuse हो गया ना? नहीं, sorry, hypotenuse नहीं, right side हो गया ना?
R by tan theta.
R by tan theta. R upon tan. Okay. So this means that the distance up to this mg, this is R by 2 tan theta by 2. Okay. And distance up to this ni, ये कितना distance? What is this distance? That means what is this yellow वाला जो मैंने यहाँ पे बनाया हुआ है? ये yellow arrow का क्या distance?
R tan theta by 2.
R tan theta by 2. This will be R tan theta by 2. Okay, so now I think I can apply the torque wala equation. So it should be Ni into R tan theta by 2, right? Perpendicular distance, plus mg into R by 2 tan theta by 2 into, I drop mg, extend mg into this distance. What is this distance? I think मैंने पहले लिख दिया है. Sorry. Drop this out. mg into what distance? mg into this distance. Now we know the length of this guy. We know this is r divided by 2 tan theta by 2. Do we note this angle? The angle मालूम है क्या? हाँ, कितना होएगा? थीटा होएगा?
हाँ सर theta.
थीटा by 2 है.
Sir theta.
फिर थीटा ही होगा ना, पैरेलल है सारे.
थीटा ही होएगा ना?
हाँ सर.
अच्छा हाँ, वो तो गिवन है ना, ये तो वर्कआउट भी नहीं करना है. तो ये जो परपेंडिकुलर डिस्टेंस आएगी, this will be equal to r divided by 2 into tan theta by 2 multiplied by this. Is correct? या sin theta है हाँ नहीं cos theta is equal to the torque due to the due to the normal reaction due to the next circle. This will be very simply r upon okay. I hope everybody is agreed with this. So now I can write a very unique relation. If you, I hope everybody can see this. The unique relation is that मैंने एक तो r को कैंसिल कर दिया, r तीनों टर्म से कैंसिल हो गया और tan थीटा बाई 2 से मल्टीप्लाई कर दिया. जब tan थीटा बाई 2 से मल्टीप्लाई मैं करूंगा तो मेरे पास आएगा mg सॉरी नॉट r mg cosine थीटा बाई 2 plus ni into tan square theta by. बहुत ही यूनिक चीज है. क्यों है यूनिक? Can anybody tell me what is so unique about this? Can you tell me what is so unique about this? Anybody tell me what is so unique about it? क्या होता है? बता सकता है कोई? नहीं. इसको इसको ना मैथ्स में इसको रिकर्जन रिलेशन बोला जाता है. And it turns out that in physics, sometimes, especially when you are dealing with these infinite these things, especially when you are dealing with infinite arrangements, then if you are, if you are observant, you will, in all probability, come across a recursion relation like this one. So basically, what this says is that look, if you know ni, then I will tell you ni plus 1. This means that if you know n0, I'll tell you n1. And if you know n1, then I'll tell you n2. And if you know n2, then I'll tell you, n3 and so on and so on and so on. So if you know n0, then you can figure out very easily what is ni. ये आया समझ में जो मैंने बोला? ni plus 1 depends upon some constant plus ni. So basically, the normal reaction by the next circle is dependent upon the normal reaction by the previous circle. Right? Okay. So let's go to the 0th circle. Right? That means that if you look at the diagram that I have drawn, then at the very left, this will be the situation. Right? At the very left, this will be the situation. ये जो यहाँ जो ये रॉड है, यहाँ पे कोई सर्कल ही नहीं. तो जब यहाँ पे कोई सर्कल ही नहीं है, तो n0 की क्या वैल्यू होगी? जब लेफ्ट मोस्ट पॉइंट पे कोई सर्कल ही नहीं है, तो n0 की क्या वैल्यू होगी? बताइए. जब लेफ्ट हैंड साइड पे कोई सर्कल ही नहीं है, तो n0 की क्या वैल्यू है? 0. क्योंकि वहां पे तो नॉर्मल रिएक्शन है ही नहीं. Therefore, n1 will be equal to how much? Now I know n0. And using this recursion relation, I can tell you, now you can tell me rather, the value of n1. n1 के लिए हमें यहाँ पे i को 0 डालना पड़ेगा. और जब हम I को 0 डालेंगे तो हमारे पास आएगा mg कोसाइन थीटा होल डिवाइडेड बाय 2। ये n1 आ गया। अब n2 क्या आएगा भाई? अगर मेरे को n1 का वैल्यू मालूम है तो मैं n2 निकाल सकता हूँ। n2 क्या आएगा? इट विल बी mg कोसाइन थीटा बाय 2 into 1 plus tan square theta by 2. Okay? Great. Now I know n2. Can you tell me n3? Can you tell me n4? Can you tell me n5? And therefore, can you tell me ni? Anybody willing to? Ni क्या होगा? ni क्या होगा? Work it out. I mean, it should be very easy. ith normal reaction क्या होगा? ith normal reaction क्या होगा? नहीं, ऐसा नहीं। जब ये रिकर्सिव फॉर्मूला आता है तो एक सीरीज बनेगी। Whenever you get a recursive formula, you get a series, and you can see, right? n3 अगर मैं लिखूंगा तो mg cosine theta by 2 कॉमन आ जाएगा। तो जब मैं यहाँ पे कॉमन लूँ 1, फिर यहाँ पे आएगा tan square theta plus tan power 4 theta tan power 4 theta by 2. So ni must be equal to mg cosine theta by 2. mg cosine theta by 2 into 1 plus tan square theta by 2 plus tan power 4 theta by 2 plus dot plus tan raised to the power how much? कितना है? ith पावर लेके चल रहे हैं। So what should I write? ऊपर मुझे क्या लिखना चाहिए? कितनी
Y.
पावर? हाँ,
2i.
2i minus 1 होना चाहिए ना, because if you look n1 में गायब है ना यहाँ पे। It should be 2 into I minus 1. Okay. This is the ith normal reaction. Please notice that physics was over at this step. This is it. This is all the physics that you require. Or you can say that up till this point. Uske baad se, this is just maths. So if I have this kind of series and I'm being asked for the normal reaction at a very large distance to the right, okay, then this means that they want us to find limit I tends to infinity, okay, of mg cosine theta by 2 into 1 plus tan square theta by 2 plus dot tan I minus 1 theta by 2. So this is just an infinite series. An infinite series having the first term as a and the ratio as tan theta by 2, right? Sorry, tan square theta by 2. So this will simply become mg cosine theta by 2, yeah, into 1 upon 1 minus tan square theta by 2. Now you must raise an objection here. What should be the objection?
Tan theta by 2 equals
मोमेंट डिफरेंस नेसेसरीली 1 से छोटा नहीं है.
हाँ, necessarily 1 से छोटा नहीं होता है tan square theta. Here we will have to assume कि होएगा, otherwise the series will become
Divergent.
very good. Series will become divergent. Now, the study of series, unfortunately, maths में भी बहुत कम होता है, but nevertheless, you will be taught the fact that series are either divergent or convergent. There is a third option also. It's called an oscillating series. But the fact is that if you have a divergent series, for example, 1 plus 2 square plus 3 square plus 4 square and so on. This is a divergent series. That means that if you start to find the sum of the series, then you are going to end up with infinities. So here, if tan square theta by 2 is greater than 1, then you are going to end up with a divergent series. And we are not really interested in that, because that tells us that the configuration of these rings and sticks is such that the equilibrium is not possible. Equilibrium is not possible, because from where am I going to generate an infinite force? So therefore, tan square theta by 2 must be less than 1. Now I think ख्याल से आसानी है, कोई issue है, ये हो जाएगा ना. m की वैल्यू क्या है? मैं फाइनल स्टेप लिख ही देता हूँ. m की वैल्यू क्या रहेगी? लैम्डा r अपॉन tan थीटा बाई 2 cos थीटा 2, और यहाँ पे है 1 minus tan square theta. So I would like to write this as cos square theta by 2 minus sin square theta by 2 into cos square theta by 2. Cos theta I can write as ये दिखाई दे रहा है, ये दोनों कैंसिल हो जाएंगे.
Yes, sir.
So this would simply become lambda r cos cube theta by 2 divided by 2 sin. Okay, so this is the answer to that question. So चलो, let's आगे बढ़ते हैं. So the second law of Newton for rotation is torque is equal to I alpha. But as we have seen, the quantities torque and I are dependent on axis. So here we come across a very weird result, which I'm not going to prove because the proof is difficult. And I don't want to get into that. But it turns out that although torque and moment of inertia are axis dependent, although torque and moment of inertia are axis dependent, alpha is independent of the axis. So if an object is rotating with an angular acceleration alpha, then it does not matter about which axis you are going to measure this alpha, it will always come out to be the same. Though about different axes, the value of torque and the value of moment of inertia will come out to be different. Now, of course, I can give you a false proof by calculating torque about 3 different axes and calculating moment of inertia about 3 different axes and finding their ratio to be constant. And so this would not be a correct proof of this, although it will happen. So the correct wala proof thoda sa lengthy hai and it involves a lot of concepts which we are not going to discuss right now. So please remember that whenever we apply this torque is equal to I alpha, we are going to get different values of torque. We are going to get different values of I for different axes. But alpha always remains the same. Okay. Now, although you are free to choose any axis that you want, but for the moment, I will suggest that you use this choice. Number one, if the object is fixed at a point, then the fixed point is the origin. And if the object is free to move, then center of mass is the object. So for the moment, we'll follow this, and later on you will see that you can effectively choose any axis that you want. Okay. So now I want to show you how to apply this. So the way that I want to show you is, I'll show you the example. Find the acceleration of the blocks of an atwood machine. Right? I'm starting with this because this is what we did Newton's laws of motion as well, right? So we are very familiar with atwoods. So we have a pulley, and the pulley is fixed about its center. We have a block of mass M1. We have a block of mass M2. The pulley itself has a radius of r and has a mass of. Now, the moment I write that the pulley has mass, okay, then things have changed very drastically from what we were doing previously. Very, very drastic change. What is this drastic change? The drastic change is that the tension on both sides of the pulley will not be equal anymore. ये मैंने फ्रिक्शन में करके दिखाया था, याद है? कराया था ना मैंने या नहीं कराया? या याद तो नहीं आ रहा है। रुको, भैया चलो, लेट्स लीव दिस फॉर द मोमेंट, फॉरगेट अबाउट इट, अभी आते हैं वापस। I have a question for all of you. Okay, now think about this question. I don't know whether you can Google it or not. The question is actually very simple. You all know now that if you have water here, then if there is an object here, right, then the image of the object as seen by an outside observer is formed somewhere here. Will you agree with this? Will everybody agree with this? Just type yes or no. I'm going to ask a very weird question, and I hope you'll be able to answer this. Okay. So the question is very, very simple. The question is that there is a bird called kingfisher. Right? In fact, there are lots of birds, but I'm just talking about this one bird called the kingfisher. Now, what the kingfisher does is that it looks at a fish inside water, then it flies, it dives inside the water, catches the fish, and comes out. All of you have seen this at some point of time in your lives on the TV screen. Now, my question is that if the image of the fish, as seen by the outside observer, which is the kingfisher as well, is not the actual location of the fish, okay, then how come the kingfisher will catch the fish? This is a very deep question. Think about it. Tell me the answer. I mean, of course, you can't tell me the answer in 1 second, but still, they might have modified eyes. How can you modify by aiming below the image? So let me answer. Modified eyes अगर हैं जो अंडर वाटर देख सकती हैं, तो वो मॉडिफाइड आईज फिर एयर में नहीं देख पाएंगे. वो किंगफिशर जब ब्रांच पे लैंड करने जाएगा, मछली मुंह में पकड़ के तब गड़बड़ हो जाएगी. अगर वो जो दूसरा आंसर आया, अगर वो इमेज के नीचे एम कर रहा है, उसको कैसे मालूम है नीचे जाना है, कितना नीचे जाना है? वाह शाबाश, बहुत बढ़िया आंसर दिया तुमने. Fish is moving upwards, then comes at a position by the time. No. It is not guaranteed that the fish is moving upwards. How can we guarantee that? In fact, fish अपनी जान बचाने के लिए नीचे जा रही होगी कि ऊपर जा रही होगी. Right? Understand? I'll tell you the answer. Shanak has given the correct answer. I'll tell you this. But before I tell you the answer, I must do some calculations. Once it enters water, it sees the actual position. ये actually बहुत अच्छा reply है, but उसमें एक problem ये है कि fish can swim. फिश के अरे खुशी फिश के टेल पे वो करे या हेड पे करे, जो अपेरेंट इमेज है तो कहीं और ही है ना. आर्यन बोल रहा है कि अगर वो किंगफिशर अंदर घुस जाए पहले, फिर फिश को देखे, फिर जाके, दैट इज नॉट पॉसिबल बिकॉज द फिश, रिमेंबर, lives underwater, right? So it is by definition much faster than the kingfisher inside the water. Kingfisher अंदर अंदर जाके हाँ yes. Question is of course how. So अगर किंगफिशर अंदर जाके फिर स्विम करना शुरू करेगा तो लोचा हो जाएगा. Then you know then things will go awry because वो fish तो फिर भाग जाएगा. And in any case, the kingfisher is using the momentum. The kingfisher is using the momentum it has built for the dive to go underwater. So it must know the exact location of the fish. It must know the exact location of the fish before entering the water itself. Right? And remember, we are not talking about आर्यन फिश ये शैलो हो या डीप हो उससे क्या, ये आपको कहाँ बताया गया है कि हाँ हाँ ओ शिवेन, हाँ शिवेन बोल रहा है परपेंडिकुलर डाइव करेगा, लेकिन शिवेन परपेंडिकुलर डाइव में भी इमेज यही आएगी. इनफैक्ट जो ऑप्टिक्स हम पढ़ते हैं उसमें हम हमेशा ब्राइट
सर इमेज ऊपर ही आएगी बट एम तो सही रहेगा ना.
वाह, वो पानी के नीचे जा रहा है, उसको अगर एग्जैक्ट नहीं मालूम है तो डूब के मर जाएगा. ऐसे थोड़ी ना होएगा कि वो सोचेगा कि मैं एग्जैक्टली तो बिल्कुल सही हो. फिश इजंट स्टेशनरी, दैट इज अनदर प्रॉब्लम. एंड द सरफेस ऑफ द वाटर दैट इज नॉट आल्सो एग्जैक्टली स्टिल. हो सकता है कि उसमें ripples हो, you know, and there's a lot of complications going on. So how does the kingfisher know? How does the kingfisher know? I mean, we are pretty sure, right? The kingfisher जो है वो IIT JEE की तैयारी तो करता नहीं है, तो उसको स्नेल स्लॉ तो सिखाया नहीं जा रहा है. बेटा देख, एक्चुअली में यहाँ होती है, रियल डेप्थ ये होता है, करंट डेप्थ ये होता है. That is not happening. So how does the kingfisher know? Shonak kingfisher advanced देने जा रहा है, JEE advanced. So to tell you, I must tell you the answer to this. And this is very weird. You know, why should I tell you the answer to this for the kingfisher? But they are intimately related. Yeah, and I'll show you how. So first, let me show you a couple of calculations. This is a pulley. And on the pulley, let's say we have a rope like so. Now, please follow me very carefully. I consider a very small part. मैं diagram बनाने के चक्कर में large angle लेके चल रहा हूँ, but I consider a very small part of the string here, which is subtending an angle of d theta to the center. So this is the portion of the string that I am talking about. Now I am saying that look, there is friction here. There is friction on the pulley. So what are the forces acting on this teeny tiny bit of rope? So I will say that look, there must be a tension T here, okay, and there must be a tension T here. This is okay. This is what we have done until now. But there is a problem. And the problem is that since there is friction here as well between the rope and the pulley, which is a real world scenario, there is friction between rope and pulley. Although I am going near a real world scenario, yet I am sort of stopping short of that, because I will assume that although there is friction between the rope and the pulley, the rope itself is massless. Okay? The rope itself is massless. रोप का मास भी आ जाएगा तो ये कैलकुलेशन और भी कॉम्प्लिकेटेड हो जाएगा, तो मैं रोप को फिलहाल के लिए मासलेस लेके चल रहा हूँ. So there must be a normal reaction on the rope, and there must be a friction force on the rope. Now the friction force must be tangential to the pulley, because we know that friction forces are parallel to the surfaces. Now I don't know where this friction force is. I can assume tangential अगर है friction, तो केवल दो ही possibility है, या तो friction इधर है या friction इधर है. I will assume that the friction is over there. Now if the friction is over there, then there is an additional problem, and that is that if, let's say, that everything is in equilibrium, then there is an additional problem that अगर यहाँ पे T and F two forces है और यहाँ पे केवल T है, you will be left with an unbalanced force. Therefore, we come to the conclusion that there must be an extra tension here. There must be an extra tension here. There must be different tensions on both sides of the little element of rope that I have chosen. That is the only way that you can factor in the concept of friction acting on that teeny tiny piece of rope. Okay. Now what I do is I draw this separately somewhere, and remember that this is part of a circle. This angle is d theta, right? मास, अगर रोप का मास आ जाएगा तो मेरे को mg भी लेना पड़ेगा. हाँ तो I'm explaining. Yeah, I'm explaining. So if I take the tension on both sides to be T, okay, then given that friction is there, okay, it is given that friction is active, then the friction may either be here or the friction may be in this direction. Friction has to be tangential, right? So it has to be parallel to the interacting surfaces. And if you look at the interacting surfaces of the rope, the teeny tiny piece of rope and the pulley, then friction must be tangential to the circle of the pulley, right? So friction must either be where I have written F, or it must be in the opposite direction. It can be either ways. I have taken the friction to be where I have written F. Now, if there is a friction in that direction, then there is an unbalanced force, because I'm saying that everything is in equilibrium. I'm telling you that everything is in equilibrium. And if everything is in equilibrium, then on the piece of rope, if I have a tension T here, I don't want to use that. If I have a tension T here, and if I have a tension T here, right, then if both are equal, okay, then they will cancel each other out. And yes, exactly. Yes. So the friction force is being balanced by the dt, by the incremental increase in tension. So what I'm saying is that as I move from this point of the rope to this point of the rope, as I move from this point to this point, the tension increases from T to T plus dt to balance the friction force acting on this piece of rope. Okay. Now, if I draw a bisector, I know that this is very small, so I'm sorry about this. If I draw a bisector, then this angle will be d theta by 2, and this angle will be d theta by 2. And the reason why I'm emphasizing on this question is that this technique, where you take a part of a circle and you say that it subtends an angle d theta, and then you draw the bisector and you say now the angles are d theta by 2, d theta by 2. This is a very common technique in physics, which we'll be using. We'll be using this in waves. We'll be using this when we study electrostatics. We'll be using this when we study magnetism. So this is a very common technique that is going to come, again and again in the future. So you must be very comfortable with this technique. Now what I do is Now what I do is I take the components of T here and here. Okay, I have deliberately taken not the vertical portion of the string. I have deliberately taken some other portion so that I can work along an axis which is not horizontal and vertical. So this will be T cosine d theta by 2. This will be T sine d theta by 2. This will be T sine d theta by 2. This will be T cosine d theta. So T cosine d theta and T cosine d theta by 2, sorry, they will cancel each other out. इसमें कोई problem नहीं है. और जो यहाँ वाले forces हैं, they will become 2 sine d theta by 2, 2t sine d theta by 2, which is equal to
साइन वाले रेड के अलोंग नहीं है ना?
नहीं, red के along. They are along the yellow line. They are along the yellow line. They are parallel to the yellow line. So this will be 2t d theta by 2, which is equal to t d theta. This is equal to t d theta. 2 और 2 cancel हो गया. मैंने क्या use किया यहाँ पे? Sin theta is almost equal to theta if theta is very, very small. Okay? Okay? Everybody is following me, right? Now,
Yes, sir.
now look at the equations. I end up with n is equal to t d theta. Okay? Because in this direction we have n up and 2t sine d theta by 2 down, which is t d theta. So n is equal to t d theta, and as we already know from previously, mu n is equal to dt, right? Because friction force is balancing that incremental tension. You will also notice कि मैंने friction के components नहीं लिए हैं और dt के components नहीं लिए हैं because I just did not, because they are I am assuming that they are very, very small as compared to the value of the tension itself. So now what I can do is I can substitute equation 1 and 2 and I can get mu t d theta is equal to dt. And I can rewrite this as dt by t is equal to mu d theta. And then I can say that, look, what I had done was that I had taken this angle as theta, or maybe this angle as theta, whichever you want, and I took this as d theta. If that is the case, then I can integrate this from t1, which two to become concept 2, यहाँ पे 2. Second equation, ये वाली equation. अरे अनम्यूट करके बोल दो तो दिखा, कोई दिक्कत नहीं. इससे which equation?
सर आपने जो फ्रिक्शन वाला लिखा है म्यू एन इक्वल टू dt वो वाला,
ये कहाँ से आया? That is what you are asking, yeah?
यस सर.
But we agreed, right, that friction is being balanced by dt.
यस सर, यस सर.
आया ना समझ में कैसे आया ये?
हाँ सर.
So now we have t1 to t2 and let's say 0 to theta. Right? So what is dt by t? What is dt by t by integration? This will come out to be ln t2 by t1 will be equal to mu theta, and this gives us the very, very weird result that t2 is equal to t1 e raised to the power mu theta. This means that the tension here, if it is T2, yes. अगर tension यहाँ पे T2 है और यहाँ पे T1 है, then T2 in this case will be equal to T1 e raised to the power minus mu into 180 degrees, that is pi radians. Now you don't have to remember this. You don't have to remember this. The only thing that you have to remember is that when there is friction between the pulley and the rope, then the tension on one side, in the same string we are talking about, then the tension on one side is different from the tension on the other side. अभी तक हमने जब भी पुली देखी उसमें टेंशन दोनों तरफ सेम रहता था, सेम स्ट्रिंग सेम टेंशन, we always used to say. We cannot say this anymore. It must be now that if the pulley has mass, if the pulley has radius, if it is given the mass of the pulley is m, then that's it. नहीं बेटा, theta is pi because you are going from one. Theta is the wrap angle. Theta is the wrap angle of string. Okay? अभी आ रहे हूँ, अभी मैं उसमें वापस आ रहा हूँ. I'll come back to it. In a minute. First, I just want to hammer the point through that the tension in the same string now, the string is the same, but the tension on two sides after the string has been wrapped around a pulley, the string has a different tension on the other side. Is this understood? Is this understood by all? अगर पुली का मास होएगा तो जो उसके ऊपर से स्ट्रिंग पास हो रही है उसका टेंशन दोनों साइड डिफरेंट होएगा. Now the statement same string same tension does not carry over, does not carry through in this chapter. If the pulley is unideal, if the pulley is non-ideal, if the pulley has mass, then tension of the string on the pulley must have different values on the two sides. Is this understood? Great. Baki log. Okay. So now to answer the Kingfisher question, and how is it related to this? How is it related to this? Anybody want to guess before I tell? Anybody want to guess before I tell? Guess ही करना है. Guess तो गलत हो सकता है. आदित्य, अंशुल, संजय, इच्छा, अपना ये कहाँ है ये पार्थ? लास्टी कहाँ से आ गया? तरुण नहीं. Okay. The answer is D. Listen carefully. You are playing tug of war. सबने खेला है tug of war? At least I don't know. मैंने तो खेला हुआ है. खेला है tug of war सबने. What is it that you instinctively do to the rope?
We pull
What?
it.
Huh? You pull it. Yes, of course you pull it. But What? Pull it back. Yes, yes. I mean, that's the game. That is the game, right? आपका फ्रेंड है, कोई क्लिफ के ऊपर से गिरने वाला है और उसने रस्सी पकड़ी हुई है और आप क्लिफ के ऊपर हो, आपको उसको बचाना है. पहला काम क्या करोगे? एंड आई एम टॉकिंग
रोप पकड़ूंगा.
हाँ नहीं, रोप तो पकड़ोगे, तो नहीं तो आपका फ्रेंड ही नहीं है बेचारा, उसको गिरने. you will of course. नहीं, you will move your feet backwards, yes, but before that there is something you will do instinctively, and that is that you will wrap your arms around the rope, right? You will not hold it just like this. You will, आप मैं क्लास में रहता तो मैं दिखा सकता, अभी तो मैं दिखा नहीं सकता हूँ. What you will do is you will take the rope and you will wrap it around your arm. Okay? You will wrap it around your right arm, or जिस arm से आप पकड़ना चाहते हो rope को, you will wrap it around that arm and you will hold the rope with the other arm. Right? Let me show you if I can draw. So if this is your hand, very bad diagram, sorry about this. What you will try to do is that you will try to wrap the rope around your hand and you will, यहाँ से आप इसको पुल करो. यहाँ से तो पकड़ा ही हुआ है, यहाँ से आपने रोप को पकड़ा ही हुआ है. You are pulling the rope from here. Rope को instinctively you will wrap around your hand. Why do you do that? Why does anyone do that? And you can, आप किसी भी tug of war YouTube पे आप देख लो.
बढ़ जाता है,
हाँ, exactly.
छूटने के चांसेस कम रहते हैं.
छूटने के chances कम रहते हैं. You know that it does not slip out. Yes, yes. But how do you know that? Because T dash is equal to T e raised to the power mu theta. Tension increases exponentially with the angle of wrap. तो अगर आप उसको एक राउंड केवल घुमाओगे स्ट्रिंग को, तो this theta will become 2 pi and this T dash will become T into e raised to the power mu into 2 pi, which is a very large quantity. But you can get a larger tension still by wrapping it around once more, so that theta becomes not 2 pi but 4 pi. And you will wrap it around as many times as you physically can to increase this wrap angle, to increase the value of T dash. Although you have never seen this in your life before. You have never seen this calculation being done before, right? But the process of evolution over millions of years, over hundreds of thousands of years, process of evolution. Once when our ancestors were, I don't know, jumping through the jungle or something, they figured out that if you are holding a rope and you are, sort of, your weight is dependent on, you are holding your weight as you hold on to the vine in the jungle, and if you don't hold on strong enough, then you will fall down and somebody will eat you. So somewhere along the line, this was hardwired into our brains. Although we do not know the maths, although we do not know this, the process of evolution has hardwired this relationship into our brains. The process of evolution has hardwired this relationship into our brains. And that is why, अगर आपको किसी स्ट्रिंग में टेंशन बढ़ानी है, रोप में टेंशन बढ़ानी है, ताकत लगानी है, you will instinctively start wrapping the rope around your hands. And the exact same thing happens with the kingfisher. Although the kingfisher does not know the maths of Snell's law, it understands perfectly what the image of the fish, it understands perfectly that if this is the image of the fish, the real location of the fish must be somewhere else. The kingfisher knows. The kingfisher has, by evolution, it is the Snell's law is hardwired into the brain of the bird. So there is no special eye thing. There is no this thing. The kingfisher knows, just like we know that if I want to hang on to my dear life using a rope, I will. तो दीक्षा एकदम एन मौके पे डिस्कनेक्ट हुई नहीं. Instinctively we know that tension is an exponential function of theta. इसका ये मतलब नहीं है कि कल को you go to I don't know, you go to a layman and the guy is pulling some rope और उसने tie around कर दिया तो आप उससे बोलो अच्छा बता कितने power से बढ़ गया tension. That nobody can tell. That of course you can work out, and if you know the maths you can tell. But this relationship is hardwired into our brains, and in exactly the same manner, the Snell's law is hardwired into the brain of the kingfisher. The kingfisher knows that if the location of the fish, if the fish image is at this position, then the real location of the fish must be this, right? And the calculation is pretty perfect if you have seen the videos on Discovery Channel. Can we pull a hanging truck by coiling a rope many times in the hand? So now the thing is that there is mathematical feasibility and there is I have this string and wrap it around my hand, let's say 20 times, then that would be T dash is equal to T into e raised to the power 40 pi, which is a huge number. तो मैंने रस्सी में दूसरे हाथ से बस थोड़ा सा फोर्स लगाया और उधर टेंशन उतना हो गया और मैंने फिर टंगी हुई ट्रक को रोक लिया मैंने क्लिप पे. So mathematically, is it feasible? Yes, it is. No problems. Physically, is it feasible? No, it is not, because then at some point of time, the string will start to break your arm. अगर आपने इतनी पतली string ली है, तो the string will cut through your arm. अगर आपने मोटी string ली है, तो आप फिर उतने circle आप नहीं बना पाओगे. But definitely, if you take, I don't know, a fixed log of wood and उसके ऊपर अगर आप ये रस्सी को coil करो, right? Then maybe yes, you can, balance a huge amount of weight on the other end. Okay. Coming back to this. Right, so there are many things. I've discussed this before also with you guys. When you are crossing a road, okay, then your brain has a very good idea about position and velocity. Very good idea. So when you are crossing a road and you look at the car, okay, if you note, please don't do this. This is not advisable. But if you are crossing the road and you look at a car, you will notice that you don't look at the car once and you cross the road. Your brain will automatically look at the car a couple of times and decide the velocity of the car, and then your brain will decide whether you can move with a velocity such that the car will not be here by the time you cross the road. Right? Of course, sometimes things go wrong uh, because of, I don't know, acceleration or because something else. Accidents happen. But the brain has a pretty good idea about velocity and position. It is acceleration where things get sort of muddled up. Okay, coming back to this. So whenever we have a problem in which we see movable objects, okay, this is the upgrade from before. Whenever we have a problem in which we see movable objects, we must classify the motion of individual objects under three categories. One, pure translation. Number two, pure rotation. And number three, rotation plus translation. Okay, now, we have not studied rotation plus translation as yet. We will, but it must be rotation, translation, rotation plus translation. If the object is executing only translation, Pratiksha, yes, rotation plus translation is rolling. Yes, we'll study that. We'll study that. So, if the object is executing pure translation, then you draw the translational free body diagram. Right? And you write down the forces on it, and you write down F is equal to ma wala equation for it. That's it. End of story. जो अभी तक करते आए थे वही करेंगे, जो ऑब्जेक्ट केवल ट्रांसलेट कर रहा है उसके लिए. जो ऑब्जेक्ट रोटेट कर रहा है, अगर हमें प्योर रोटेशन दिखाई दिया तो हम उस ऑब्जेक्ट के लिए एक रोटेशनल फ्री बॉडी डायग्राम बनाएंगे और उस ऑब्जेक्ट के लिए हम टॉर्क इज इक्वल टू आई अल्फा इक्वेशन लिखेंगे. उसके बाद से हमें ये देखना पड़ेगा कि इस सिस्टम में जो भी आपको दिया हुआ है, सिस्टम में कंस्ट्रेंट्स क्या है. Now I know that constraints is always a word which sort of conjures up weird equations, but here the constraints are going to be very, very easy and manageable. Okay? Let me show you how it is. So first I look at M1 and I see that it is translating. It is having only the motion of translation. So I draw M1G E1. Now I am assuming, you can assume otherwise, you can assume something completely random. You can assume whatever you want, but you have to be careful. I am assuming that this guy is moving up and this guy is moving down. And therefore this guy is moving clockwise. I am assuming that M1 is moving up, M2 is moving down, and the disc is moving clockwise. The pulley is moving clockwise. You can assume the other way around. You can assume both of them going up and the pulley going anti-clock. You can assume anything. If your assumption is wrong, you are going to get the negative answer. If your assumption is right, you're going to get the positive answer. So the equation that I will write here will be T minus T1, sorry, T1. यहाँ पे tension is T1. यहाँ पे tension is T2. T1 minus M1G is equal to M1D. Please also notice that acceleration will be same. A will be same. because the fact that the pulley has mass results in the phenomena that the tension on both sides of the pulley in the same string have changed, are different now, but the length of the string remains constant. This means that if M2 moves a distance x down, then M1 must move a distance x up. Therefore, their linear accelerations must be same. If M2 was connected to a different pulley, of course, then the acceleration would not be same. For M2, we have translation, and therefore I will draw the free body diagram for M2, E2, M2G, and I will write down M2G minus T2 is equal to M2. And then we come to for M, for the pulley itself. Pulley is undergoing pure rotation. So we draw the rotational free body diagram. Forces acting as and where they act on the system. T dash, T2, T1, Mg. And we remember the advice that if the object is fixed, then the fixed point is the origin. In this case, there is no problem because the fixed point also happens to be the center of mass of the pulley. So this is the fixed point. This is the origin. So now we need to calculate the torque about the origin. And that will be equal to T1R and T2R. Force multiplied by perpendicular distance. Now, you will notice that I have not written the signs. The reason is that just like we have written the equations of motion here and here, in exactly the same way we are going to write the equation of motion here. What does this mean? Well, if the acceleration of M1 is assumed to be T1 will not be twice known. Just look at this pulley. पुली के कांटेक्ट में स्ट्रिंग यहाँ है, यहाँ से T1 से पुल कर रहा है, यहाँ से T2 से पुल कर रहा है. That's it. So just like we assume that the acceleration of M1 is A upwards, therefore I take T1 greater than mg and I write T1 minus mg. And if acceleration of M2 is A downwards, so I take M2g greater than T2 and I write M2g minus T2. In the same way, here if I have concluded that or I have assumed that the rotation is clockwise, okay, then this means that all clockwise torques will be positive and all anti-clockwise torques will be negative. So T2 का जो टॉर्क है clockwise है, T1 का टॉर्क है anti-clockwise है. So here I will write down clockwise torque positive, anti-clockwise torque negative. Okay? And this will be equal to I alpha. And a pulley by definition is a disc or a cylinder. Therefore, its I is mr square by 2. So we get T2 minus T1 into R is equal to mr square by 2 alpha. A very important thing which I think I missed out, I must write here, that torque and moment of inertia must be calculated about the same axis. Okay. So this is the torque wala equation for the rotating object. Now we come to constraints.
सर आप m के लिए एक बार बता सकते हैं क्या?
कैपिटल M के लिए
यस सर.
कैपिटल M के लिए क्या बनेगा उसका FBD सेंटर ऑफ मास से mg एक्ट करेगा, सेंटर से ही एक टेंशन एक्ट करेगा which is the force applied on the pulley by the hinge, by the object that is holding the pulley in place. Then due to the string on the left hand side there is T1, due to the string on the right hand side there is T2. Tension T2. This is the origin. The perpendicular distance of this force is R. Perpendicular distance of this force is R. P dash and mg, they are passing through the origin itself. So the torque on the pulley will be torque due to P dash, torque due to mg, torque due to T1, torque due to T2. This will be 0. This will be 0. This will be T1R. This will be T2R. Now, since I have assumed that the thing is going clockwise, therefore the clockwise torque will be positive and anti-clockwise torque will be negative. The way to know, the way to see is very simple. Keep your pen on the arrowhead of the force and you turn it towards the origin. If it turns clockwise, then the torque is clockwise. If it turns anti-clockwise, the torque is anti-clockwise. So this will become minus and this will become plus. आया समझ में लड़का? Any doubts in this? बताओ लड़का आ गई. Confused with the clockwise and the anti-clockwise. Okay. देखो. Forget about everything. If you have a fixed disc which is fixed at the center and you apply a force like this, right, looking at it from the top, of course, will it turn clockwise or counterclockwise? Looking at it from the top, will it turn clockwise or counterclockwise? अगर ऐसे force लगाया तो, that's it. That is the direction of the torque. And if I apply a force like this, then will it turn clockwise or counterclockwise? That's it. That is the direction of the torque. ठीक है ना? एक mental help, एक mental aid जो मैंने बनाया है वो ये कि you keep your pen on the top of the force arrow and you turn your pen towards the origin. You are turning it clockwise, clockwise torque, anti-clockwise, anti-clockwise torque. Okay, now the constraints. Constraints are extremely simple. The acceleration of this point on the string and this point on the string must be same. Acceleration must be same. Okay, because there are 2 points on a string. If the acceleration is not same, then the string will break or it will become slack. Either of these things we can't have. So if I have a rotating object, like this clockwise object, then what is the acceleration of this point? What is the acceleration of this point? You remember from angular motion, from rotational motion. If the angular acceleration of the object is alpha, then the acceleration of this point must be r alpha. 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 याद है ना ये सबको? Acceleration of this point must be r alpha. Acceleration of this point must be r dash alpha. Acceleration of this point must be r double dash alpha, and so on and so on. याद है ना? Tangential acceleration होता था distance from the axis multiplied by alpha. So the acceleration of this point will be r alpha, and the acceleration of this point we have already assumed as a. So the constraint equation is a is equal to r alpha. Okay. Now let's solve all the equations. I think we should be able to solve now very easily. I'll solve it on a different slide here. Let's say तो पहला इक्वेशन है मेरे पास T1 minus N1G is equal to M1A. दूसरा इक्वेशन है मेरे पास M2G minus T2 is equal to M2A. उसके बाद मेरे पास इक्वेशन है T2 minus T1R is equal to MR square by 2 into alpha. चौथा इक्वेशन है मेरे पास A is equal to R. Okay, so we are not going to write the equations like this that I have written. We will write it like this. T1 minus M1G is equal to M1A. M2G minus T2 is equal to M2A. T2 minus T1 is equal to MR by 2 into alpha, which is A by R. So this becomes MA by 2. Add them all up. Get M2G minus M1G is equal to M1 plus M2 plus M by 2 into A. So A is equal to M2 minus M1 into G upon M1 plus M2 plus M by 2. This is the almost same equation as a normal Atwood machine, except for the fact that there is a capital M by 2 in the denominator. Okay. So if we actually carry out an Atwood machine experiment, real life experiment, and calculate the acceleration of the blocks, then the acceleration of the blocks, if somebody calculates assuming an ideal pulley M1 minus M2G upon M1 plus M2, if somebody calculates like this, then this answer will be closer to the actual value. It won't be exact, of course, because we are still assuming the mass of the rope to be 0. So it won't be. A very important thing again that I have missed out on, and you will keep on seeing this, is that find the acceleration of the blocks of an Atwood machine. Assume no slipping. Now, अभी तो मैं लिख दिया, भूल ही गया था लिखना, but ये मैं लिखूंगा नहीं generally, right? So our assumption will always be that there is no slipping, right? At the end of the chapter, when we have finished the basic concepts, we'll talk about what happens when slipping occurs. Why is this? अगर slipping हो गई तो ये constraint follow नहीं होएगा. So this is only in case of no slipping. Okay. चलो मैंने बोल दिया, अब आप लोग करिए. Find acceleration of log. Okay, assume no slipping. हाँ हाँ उत्कर्ष करते जाना, सही कर रहा है, करते जाना. करो. हाँ शायद बिल्कुल। कौन सा वाला बता रहा है? नहीं, दोनों मास सेम है ना? दोनों मास सेम डाल। हाँ तरुण बिल्कुल सही है। हाँ अरुण, यस। नहीं चैतन्य, 2G नहीं हो सकता है ना, आंसर G से ज्यादा नहीं हो सकता। आंसर कैन नॉट बी ग्रेटर देन G, नॉट पॉसिबल। हाँ वेदांत सही है। हाँ चैतन्य अब सही। यस सही है निश। आगे वाला करो, बाकी तो करो। Ooh, that's अरे वेज फिक्स्ड है दादा। वेज फिक्स नहीं होगा तो अभी फिर कल तक लगेगा निकालने में। कितना निकाला उधर? G/8।
यस सर।
3 इक्वेशन और 2 कंस्ट्रेंट लिखे, मतलब 5 इक्वेशन लिखी उत्कर्ष।
हाँ सर।
So the equation, the first one will be mg minus t is equal to ma r is equal to mr square by 2 a is equal to r alpha. When you put the value of alpha and everything and you add it up, that mg is equal to 3ma by 2. So 2g by 3 is equal, यहाँ पे टेंशन T1, यहाँ पे टेंशन T1, गुड, यहाँ पे T2, लिखूं मैं सेकेंड वाले के इक्वेशन? इसके लिए P1 minus M1G sin theta is equal to 1A. So I'm assuming that this is A, this is A, this is alpha. In this case, I assume that this is A, this is alpha. Because there was only one torque, I had no need to decide about clockwise and anti-clockwise. इसके लिए जो इक्वेशन आएगा that will be M2G minus T2 is equal to M2A. T2R minus T1R is equal to MR square by 2 alpha. A is equal to R. हाँ, ये बिल्कुल वही एक्सप्रेशन है जो हमारे पास एनएलएम में आया था, बस नीचे n/2 आ जा रहा है। अगर आपको ये एडवर्ड मशीन का कोई भी वेरिएशन आया, नंबर नीचे बस n/2 ऐड कर देना है, बाकी सबसे। इसके लिए I will assume A, I will assume alpha 1 and I will assume alpha 2. So we get mg minus T1 is equal to MA. Get T1R minus T2R is equal to M into R square by 2 into alpha 1. Then we get T2R is equal to 3M into 2R whole square by 2 into alpha 2. कहाँ पे T2 बेटा? कहाँ पे? अच्छा, अगर किसी भी पुली के पास अगर मास है, if a pulley has mass, then anywhere this will be tension T2, this will be T2. And you can find the values actually now. Let's say, okay, if this is the angle of wrap, then T2 is equal to T1 e raised to power root theta, or T1 equal to T2 e raised to power root theta. Either ways, जो ज़्यादा है। But अगर रैप एंगल जरा सा भी हो गया, तो टेंशन चेंज हो जाएगी। The constraint relations will be A is equal to alpha 1R. ये कैसे आया? इसका एक्सेलरेशन A है, इस पॉइंट का एक्सेलरेशन alpha 1R है। इस पॉइंट का एक्सेलरेशन alpha 1R है और इस पॉइंट का एक्सेलरेशन alpha 2 into 2R. So we also get alpha 1R is equal to alpha 2 into 2R. क्या 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 निकाल दिया भाई? आ गया cos थीटा कहाँ से? रिमेंबर, ये बात सुनो आ रहे ध्यान से। बेस्ट पार्ट अबाउट दिस थिंग रोटेशन वाला इसकी पुली के ऊपर जो स्ट्रिंग रहती है never almost components of tension because tension will be tangential to the pulley. हमें तो केवल परपेंडिकुलर डिस्टेंस निकालना है. Very good question. Now, look at the red marks. Look at the red arrows that I have made. Exactly. Yes. Just like पहले वो नीचे जा रहा था मास, जैसे हम न्यूटन लॉज ऑफ मोशन में करते हैं, नीचे जा रहा है तो mg को पॉजिटिव ले लिया, टेंशन को नेगेटिव ले लिया. अगर ऊपर जा रहा है तो टेंशन पॉजिटिव ले लिया और वो नेगेटिव ले लिया. ठीक है, इसका आंसर बता दो कोई. सी वाला g/8 है, उत्तर का आया था या कुछ और. मुझे g/5 क्यों आ रहा है उत्कर्ष? 6 हाँ 8 है, हाँ सही है g/8. हाँ सही. इसका आंसर आएगा g/8. ठीक है, क्लियर है ना सबको भाई? कोई कोई डाउट तो नहीं बचा ना? लिंगरिंग डाउट प्लीज आस्क, डोंट कीप इट विथ यू. हेलो
यस सर.
हेलो हेलो. नींद आ गई लग रहा है सबको, सब सो गए. नहीं, T1 के कंपोनेंट्स लेने की जरूरत ही नहीं है. व्हाई डू यू नीड कंपोनेंट्स इन द फर्स्ट प्लेस? Extend the force and drop the perpendicular. That is how you find torque. You don't need to take components while finding torque. Okay. Chalo. So I will say goodbye and we'll meet in the next class. We start with HCV now. Next class we'll do rotation plus translation. Chalo. Bye bye.